Um, the experience was amazing because I've not heard about a lot of things mentioned there yesterday, like the security part of the blockchain compliance, the blockchain um, investigation, and every other thing that helps in securing and protecting the users in blockchain. So that was the most interesting part of that meeting yesterday because I paid so attention when the lady was saying a lot of things about the stuff, and the thing caught my attention. I even decided to make some research on it and know how it works. So that's the only thing I paid attention more on that meeting yesterday. Thank you, sir.
Okay, thank you very much. That's interesting also. At least we had more exposure yesterday because, of course, we're listening to experts in the industry or in the space. So we'll take one more experience before we begin our lecture today. Who wants to go? Precious, good evening. If you were on the space yesterday and you'd like to share your experience with us, just show by a raise of hand so that you can share your experience with us. Okay. Precious, you're clapping, you can go. Okay. Tell us your experience on the space yesterday.
Okay, so yesterday was one of the times because I got to learn from industry experts, especially the forensic woman. She actually kind of let's say relate more to me in the sense that it was really nice seeing a woman doing something so good when it comes to blockchain. Like, when our mentality where they say women can't do some certain things and see somebody excelling. So like just listening to her alone gave me the drive to just stay focused and be good at what I'm doing, be good at what I'm learning right now. So that as time goes on, I too will be called upon to, share my experiences and give lectures like that on Twitter spaces. So apart from that, um although my network was really really bad because after their introduction and everything it just logged me out and I was trying to log back in, but from the little I heard I also had a wider knowledge of when it comes to blockchain and how the whole checking thing is done, especially with guy that asked a question regarding criminology and stuff like that. So it kind of broadened my horizon to a whole new level, and I just really want to thank Ethereum Nigeria for the opportunity.
Thank you too for, okay.
Okay, guys, welcome to this session. We're already 8 minutes into our time, so Etita is here, Trina. So everyone is ready for hands-on, right? So let's catch the fun. It's good having your feedback towards yesterday's space. So we want to do much more, and I can hear someone saying she can't wait to speak or mentor others on space. Yeah. So what are we saying? So we don't need to look for outsiders. It's we. So we want to see you guys placed in position, and then we'll call you guys, to mentor, to reach out, to support, and all those things. Toby was one of my friends some years ago, and now he's in UK, highly placed, and so that's a network and opportunity to, so that's what we're all about. So without much ado, over to you, sir.
Thank you very much, sir. Good evening again, everyone. Today is a continuation, and today is our third lecture in the second week of our bootcamp. And this week we of course dealt on smart contracts and the Ethereum blockchain. So on this hands-on, practically, we're going to explore smart contracts. We're going to look at how they actually work in real life, and we'll do that by creating a token. So I know most of us are not developers, but let me share my screen first and foremost. So like I said, I know, I hope you guys can see my screen now.
Sure,
Okay.
we can see it.
So basically, today we are going to explore how smart contracts work, and we are going to use, of course, this programming language that was actually developed for the Ethereum blockchain, which is Solidity. But since most of us are not developers, we are going to use a platform. They call it a no coding tool. So we use a platform to actually deploy our token. So, but before then, before we go into that, the prerequisite, of course, we have to have our MetaMask on our browser. So right here, you can see my mouse. This is my MetaMask. If you don't have MetaMask extension on your browser, it's easy. You just go to metamask.io. So yeah, you can see the download here. So all you have to do is just click on the download. But I already have it installed, so it will prompt you to install it on your SIM. Install MetaMask for Chrome, but I already have it installed. So this is how you install MetaMask. Then after that, okay, first and foremost, let's just look at how the code works, right? So let's use Open Zeppelin. Like I mentioned, Open Zeppelin provides standards for smart contract. That means the smart contracts that are written have been audited and they are security proof. So basically, you can just create a token with Open Zeppelin by just getting the code and deploying it. So we'll just look at that before we use the thing, openzeppelin.com, before we use the no coding tool here. So if we go to Open Zeppelin, now it's quite easy to use, right? So we'll just give it a minute to load. Okay, it's quite easy to use because it just asks you what you want to do, the name of your token. Then it writes the smart contract for you, which of course you can copy the smart contract and use a platform like Remix to deploy it. So we'll just look at that briefly. I'm waiting for it to load. My network is done to come up. But then if you've not had your MetaMask installed, please try and install your MetaMask browser. And this thing is taking a while. Okay. So we'll just move on. All right. So after installing maybe we'll just come back to it when it's loaded. After installing your MetaMask, you should have something like this as the extension. This is actually a testnet, right? So for the purpose of this class, let's just start from beginning. So I'm going to add a new account to my MetaMask. We'll call it Ethereum Nigeria. Okay. So now I have an account with Ethereum Nigeria on. Okay, we'll use a testnet. So let's use Sepolia testnet. Actually, before we continue, we need some money to pay gas. So we need some testnet to pay gas. Now, some testnet tokens to pay gas. So basically, the testnet and the mainnet. The mainnet is actually where you actually have the real value for the asset, like the one you pay money to buy coins or you exchange coins for fiat money. So, but the testnet is exactly the same thing as the mainnet, just that the testnet was made so that people can test their smart contracts before actually deploying it to production. So on the testnet, first we'll need some, like I mentioned, some test facets and test tokens, sorry. So you get test token from test facet. There are many test facets. So for the purpose of, you can go to Alchemy for the purpose of the class. We'll just go to Alchemy, but if you don't like Alchemy, of course, you can just Google for Ethereum testnet facets, I think, but we'll just go to Alchemy, right? So go to alchemy.com. So basically, in alchemy.com, we can actually get some testnet. Okay. Okay. The best facet, yeah, exactly. So you are looking for. So this is actually where we can get the facet, but it's an affiliate of Alchemy. As you can see, it's powered by Alchemy up here. So we need Ethereum sapling. All right. So what we do is we copy our wallet address. We copy our wallet address and then we just paste it here. Okay, I think we need to sign in first. Okay. So you need to sign up, of course, but I already have an account, so I just logged in. So I'll paste my wallet address and I'll check the captcha. Then I'll just send. It's as easy as that. So just wait, it's the blockchain, so it's going to take a while before we get our facets. Let's see. Okay. Just to confirm, of course, remember it's the blockchain. We can always see. So you see here it's for Sapolia testnet. So let's see. Yeah, 0.5 hectare was sent. Let's check. Okay, so we have a balance of 0.5 hectare, and if we should check our MetaMask, we should actually see 0.5 hectare. All right, so we see that we've received our 0.5 Sapolia hectare for the testnet. So we'll go back. Let's see, this guy has loaded. Still a problem. So basically, we'll just use third web instead. So I hope we've gotten to this point where we can actually get test facets for our MetaMask. So we can now go to the no coding platform I mentioned before. It's called TEDWeb. I think yeah, TEDWeb.com. It's a platform you can actually use it to build many stuffs without actually writing a line of code. So I think we need to sign up for login. So okay. It's asking to connect wallets. So we connect our wallets, MetaMask wallets. Okay, so yes, we are going to connect.
Daddy.
Yeah. Did you say something? Oh, okay. Please mute. I'm not speaking, please.
Let's buy suya now so that everybody that you're coming back. Give me the money, I'll buy and come.
Chechi, can you kindly mute? Thank you. Alright, so continue. So notice we are using the Ethereum Nigeria wallet address I just created. So connect the wallet address so that okay, it's asking to sign. Now remember, the blockchain is not just about sending transactions. Of course, you can sign transactions like you see. After connecting my wallet, it's actually asking me to sign. So it's like an approval to connect the wallet. But as we are going, if you have any question, please feel free to call my attention to it. So sign on. Of course, we see that our wallet is connected here. So it's asking for an okay. Let's create. Okay, better. Go ahead, please. Your hand is up.
Please, good evening, everybody. I already put my question on the chat session, but I'm a bit lost. No, I didn't just join now. I was using my phone to join, but I've joined with my laptop. But I'm a bit lost. I don't really get it. I've been watching you do it, so but I got confused. I don't know if you don't mind. Can you
Okay,
please
just
go
hold
over
on.
it again?
Hello, but just hold on. You can always watch the video later. Let me just finish what's in. It's recorded. We'll share the links and we'll answer your questions later on. Thank you.
Okay. All right. So we'll answer your questions later. So for the rest of us, I'll be following along. When you connect your wallet to TEDWeb, it's asking for an email, so you signed up since it's a new account. Then they send this code to your email, then you just verify. All right, so wait for that to load. Remember, basically, I don't want to add payment option. Okay. Okay. Don't know why the payment option keeps coming out. I think this is new. TEDWeb is actually free to get started with. All right. But this is actually new, so okay. Yeah, just give me a minute to fix this and we'll join back. I'll just stop sharing my screen so that I can fix this. But in the meantime, Betters, I can answer your question. Better, please, can you ask the question? You're asking me what I was doing or something.
I know what you wanted to teach us, or you are rather teaching us how to deploy a smart contract on the blockchain, and you started with opening the open Zeppelin, and after that, that's where I got a bit lost because I
Okay.
equally opened the open Zeppelin with you, and
Yeah, the
at
problem
that
with
point,
Zeppelin is that it was taking a while to load. So because it was taking a while to load, actually I wanted to show us what the code looks like, right? So maybe I'll just try and look at it. Let's see if it has loaded. I wanted to show us what the code looks like, and of course how you can actually do that using the code before showing us third web. So maybe I'll just look at that in a minute. We'll look at that together, of course. So, okay, I think I've fixed that problem, so I can share my screen now. Okay, hope you guys can see my screen now. Okay, so I'll just continue. I hope you guys can see my screen. So now I fixed that problem. So on the third web page, basically you have, once that problem is gone, you go to the home page here, right? So you have different things. So you can come to this contract. You can see they have contract already pre-built. You can deploy. You can actually build your own contract. You can interact with your own contract or other smart contracts. But for the purpose of this class, of course, we just want to deploy a simple ERC20 token. And maybe by the end of the class, those that have been following along, I will send some of these tokens to some of you. If your wallet, of course, is on the Sepolia testnet, remember how we got there? So we'll just try to deploy a simple contract, right? A simple ERC20 contract. So we go to deploy contracts, of course, to choose the contract you want to deploy. There are other things that third web offers, like decentralized autonomous organizations and NFTs and marketplaces. Of course, these are some of their popular contracts you can deploy. Like I mentioned, NFT drops, marketplace, account factories, of course, token, and all of this. So there are a lot of them. You can check them out, of course. But for the purpose of this class, we just want to deploy this simple ERC20 token. Now, ERC is actually a standard token on the Ethereum blockchain, which allows for store of value. This value can be transferred between parties and all of that. So that's basically the logic in the smart contract of tokens. So we're going to deploy this ERC20 token. Here on this part, for developers, of course, and these are functions, right? So you can approve, you can burn, you can decrease allowance, and all of these. These are all functions. These are all terms and conditions of this ERC20 smart contract. Of course, this one is just to write. So it's going to cause a change in the state of the blockchain. That means for every time you call any of these functions, like to send token to someone, or to burn the token. By burning the token, you are destroying that particular token. So every time you make that call, since it's a write function, it's going to change the state of the blockchain, and as such, you pay for gas. But there are other ones like these ones that you have the read. So most of these read functions, except in some rare cases, most of the read functions don't cause gas. Like for instance, to see someone's balance, it doesn't cause gas. So read functions, read logics, like by read, I mean like they read from the blockchain, they read information or data from the blockchain, and the write also writes information or data to the blockchain. So without much ado, we'll just come to deploy now, right? So we'll go to deploy now. It's going to ask us the name, of course, the name. So we're going to use the name of our token, of course, is going to be Ethereum Nigeria. So the symbol, just like you have Bitcoin, BTC, Ethereum, or ETH, of course, Polygon, Matic, and all of that. So let's call our symbol ETH Nigeria. So we can always add metadata to it. You can add a file, of course, but we wouldn't want to do that. We'll just give you the description. Let's call it a simple. Yes, no, let's see. Um, let's leave our description like that. All right. So we are going to deploy this token. Normally, tokens have what they call maximum supply, it's like a pre-mint. So this maximum supply is like how many tokens, how much of these tokens do you want to be in circulation, total circulation, right? So we know Bitcoin is like 22 million tokens in circulation, but other Ethereum actually, Ether doesn't have a total supply, right? So Ether is always minted, it doesn't have a total supply. But there are other cryptocurrencies and tokens that are within a billion plus and all of that. But for this ERC20 token, of course, we are not going to specify a total supply. So what we are going to do rather is after deploying the contract, we are going to mint a particular amount. Then after minting the amount, we are going to share it. Let's just distribute it to people that are on this core that are actually on this Sepolia testnet. So, okay. Right, I think that's all we need, and we'll just click the deploy button down. Of course, we're going to ask for our wallet so that we can actually sign the transaction since it's a blockchain. All right, we'll just wait for it to connect. Okay. So yeah, this is the gas fee you are paying. This is actually Matish. Okay, we just go. This is the gas fee you are paying, and we just need to confirm the transaction, of course. So you can see now we have 28 confirmed transactions, meaning that this token has been deployed on the testnet. We didn't write any single line of code, right? But we have a token on the testnet. Of course, I have to sign. So yeah, we've successfully deployed our token on the testnet. And of course, remember we have the Explorer and all of that. So we can always confirm that this token is actually deployed on the on-chain on the testnet. So we'll just wait for ThreadWeb to load up. ThreadWeb is a platform, like I mentioned, that help people that don't know how to code to actually build or deploy stuff on the blockchain. They already have predefined smart contracts that you can take and deploy, but it's always advisable to like read through the documents of the smart contract before you actually deploy it. So ThreadWeb is taking a while. But there's another way we can do that, right? So let's copy the wallet address and check. It should tell us this is actually Matif. We deployed it on Matif. Okay, so that means we have to go to Mumbai, Matif Mumbai. Okay, so we'll just paste the wallet address. So we can see that we have a transaction from 1 minute ago. So this is the hash of the transaction. So we'll just open it so that we can see it better. All right, so 2 minutes ago, This is our transaction hash, like the receipts for deploying the smart contract. So this transaction hash is unique because every time you search for it, it's always going to pop out this particular transaction. And of course, we can see the amount of mileage, the gas we paid. And here, if you notice here, this is what we talked about yesterday. So this is actually an EOA, externally owned account, because it belongs to a human, an individual. But this is the contract address. And if you notice, the contract address has this small icon here. And if you hover over it, it says it's a contract, right? So see that you can use your account to actually deploy a smart contract. And these smart contracts, since they don't have private keys, they are actually called contract addresses. So at this point, this is the address of the smart contract. Anybody can get this address and interact with the smart contract. Of course, if you permit it, remember, it depends on your logic on your smart contract. There are some smart contracts that only the account, only the wallet address that deployed that smart contract can actually interact with that smart contract. Sometimes it's for security reasons or whatsoever the logic has to do with the smart contract. So basically, let's just check the smart contract and let's open it. Remember, we're using our Explorer here. So we can see that this smart contract actually, okay, it has no value right now. It has no total supply. So let's fix that. Let's go back to third web contracts. So these are contracts. Still no contract address provided. Why? Okay, so now we have our contract that has been deployed, our token. We just wait for it to get all this information. So remember our token symbol is ETHNG. So you can see our total supply is 0. And I've not minted anyone yet. So I have to mint it to a particular wallet address. So okay, let's mint some. So let's mint our first token. So head to the token tab to mint it. Alright, so at this point we can mint. Let's mint 100 of it. Okay, let's confirm to it. So normally, remember when we said on the blockchain transactions take a little while. So it's one of those challenges we mentioned in class. I have a confirmation. So the difference is that Polygon, I noticed that my wallet switched to Polygon. So on Polygon, it's actually layer 2. So the transactions are kind of faster. So if we're dealing with Ethereum directly, it may take a little while longer. So those are some of the challenges we mentioned when we talked about the challenges on the blockchain space. So it's for faster transactions. There are a lot of technologies coming out that are actually promoting cheaper and faster transactions. So now we can see that we have 100 of our Ethereum Nigeria in total supply, and the 100 of it is minted to the wallet address that deployed it, meaning my wallet address, of course. But the thing is, the tricky thing is that if we come back to, of course, my wallet address, we will not see it. So why is that? So we'll come to the tokens. Yeah, so we don't see it. We don't see our Ethereum Nigeria token. So the question becomes, well, why is that? Remember when I said that anybody can interact with the smart contract, right? So anybody that has the address of the smart contract can interact with the smart contract. So what I'll do is I'll just come over here to the contract. I hope I'm getting the right address. Let's see. Okay, so this is the contract address. So I'll copy it and I'll go back to my MetaMask. Then I'll import tokens down here. So once I input the address of the contract, token detection, symbol must be 11 characters fewer. Or what did I? Okay. Hmm. Then I'm getting the wrong. Let me get it from TEDWeb. This is the contract address from TEDWeb. So let me copy it. Let's try that again. So um, okay. Let's just import it. All right, so this is the right contract address. As you see, I didn't have to fill this up. It did fill up itself. I need to check the one on the Etherscan again. So the right contract address always pops everything up for you. So I'll just import that. You can already see that it knows that my wallet address holds 100 of it, right? So once I import that, of course, you can see my token here. This one is the fake one. I'll just delete it soon. But this token here, we have 100 Ethereum Nigeria tokens. So basically, we're able to actually deploy, create and deploy an ERC token without writing one line of code, right? So you can also use TEDWeb for many things, NFTs and a lot of it. So, but let's look at just in 5 minutes, let's try to look at Open Zeppelin again so that we see how it really works. That's what I want us to really see. How the contract looks like and how it really works. I'm seeing questions in the chat. Let's see. I'm not understanding. I'm sorry for the voice. I must attendance. Okay, yeah. Attendance will be available soon, guys. So Okay, yeah. So guys, this is what a smart contract actually looks like. The ARC token we just deployed, of course, that was on third web. We didn't write a line of code, but what Open Zeppelin offers is the same thing, right? So, like we mentioned, we can just come here and notice how the code changes. So, if we want to deploy our Ethereum Nigeria token using Open Zeppelin, as you notice here, the name of the token has been is called a constructor. So this is like the programming language, this solidity, right? So basically what we did on third web was just this was what was happening on the background, but third web did not show it to us. So if we have our Ethereum Nigeria and of course ETH, just so that we can differentiate, right? So I'll use small n and a big G. Okay. So now we have options. Open Zeppelin offers options, so we can make it mintable, meaning that we want to actually mint a particular amount to any wallet, right? So we don't want to mint only to the wallet that deployed it. We want to mint to any wallet. So we can make it burnable. There are other options here, but we're trying to keep it simple, right? So if we wanted to have like a total supply of our tokens, we don't want to be minting it. So you see the pre-mint here, we can just add our total supply here. And you see that it's here. You can see it here. So that would be the total supply because it's minted just once you deploy the smart contract. But we don't want that to be the case, or I don't want that to be the case for this. So basically, Open Zeppelin just offers us the smart contract. So this is what the smart contract really looks like. This Solidity programming language. So most times it's a lot more complex than this, but this is just for educational purpose. So we just do the same thing, try to also mint another token. I think, uh, okay, the name shouldn't bother. All right. So now after getting the code from Open Zeppelin, you see you can copy the code and of course go to any there are a lot of platforms, and of course it gives us the option of Remix. Now Remix is also a browser tool. It's not completely no coding because it just helps you to compile your code and deploy it. So let's use Remix. Remix often takes a while to load. So in the Remix, remember we are getting our smart contracts from Open Zeppelin. We didn't write it, of course, but we just defined what we wanted, and Open Zeppelin helped us write the code. Then we are opening the code with, of course, Remix. So this is the code here. This file, there's a file. All right. So this is the code. That, of course, you see, it's the same thing with that from Open Zeppelin. It's the same thing. So here in Remix, we can compile the code and then deploy it. And then we can also always, once we deploy it, it will return to us the wallet, the contract address, which we can use to verify on an Explorer. And then we can also use that same contract address to import this token in our MetaMask. So basically, we just if you're using your laptop and you are here, all you have to do is go to the file, of course. Don't change any line of code, just save it like Control S so that it can compile. So we'll do that, we'll save it. If you look here, somewhere here, you see it's trying to compile. So basically the code has been compiled, meaning it has been kind of converted or translated into byte code. So remember we said computers understand zeros and ones. So this code now has been compiled into byte code. And I'll just show you here. If you come down here, somewhere here, you see copy byte code to clipboard, but it's quite long, so we'll look at it. So after, of course, compiling your code, there's an icon down here to deploy it. Now, Remix is wonderful because Remix already gives us all these demo Ethereum wallets with at least 100 Ethereum each. so that we can test out different things. But in this scenario, we want to actually use our MetaMask wallet so that you can see our token in our MetaMask wallet. So in the environment up here, we can just come here and select injected provider. Of course, it's going to pop up our MetaMask, and yeah, it's gotten this normally is supposed to pop up, but I think I've connected on Remix before, that's why. But in your case, it will pop up, ask you to sign, and once you sign, of course, it will retrieve your wallet address. And of course, your wallet is connected. My wallet is connected right now. So in this case, I'll just copy my same wallet address because remember, I want to deploy it. So it's going to ask for initial owner, right? So remember when I said that some smart contract logic, only the person that deploys the smart contract can call certain functions. Okay, so in this case, if you look here, you see this enable. So OpenZeppelin has a standard called enable where if you use enable, remember we ticked it here. It was part of the options I ticked here. Let's come up right here, enable. So this enable means I want to be the only one to interact with this smart contract. I don't want another person to interact with it. So that's why we are having this enable. So to deploy the smart contract, you can provide a wallet address. It might not be your wallet address, right? So it could be any wallet address. Once you provide it in this place, this page, I provide my wallet address, and of course, I deploy it by clicking on this transact button. So if I do that, this is a bit technical. Okay, it's going to pop up my MetaMask so that I can sign the transaction and of course confirm the transaction. So after doing that, normally we have to wait for a while. All right, so we have 30 confirmations. That was very fast. So now if we look at the logs, hope this can go up. All right, let's see. So if we look at the logs now, you can see that we have deployed this Ethereum Nigeria is the name of our token, and this is the owner of this token. Remember, we did not specify how many, we did not specify a total supply. So basically that's that. So just to confirm, this is the contract address also, right? So it gives us the contract address. So copy the contract address and we'll still go back to, okay, this is on Polygon, yeah. So let's search for the contract address on Polygon. Okay, so, right. This is the contract address. You can see contract creation 54 seconds ago. So we can use Remix or we can use ThreadWeb. So the next thing is how do we mint, and of course so that we can see it in our wallet. So to do that, after deploying the smart contract on Remix, of course, you can see it here in deployed smart contracts. Let me get this thing up. Let's see. All right. So here you can see our smart contract that we just deployed. Remix, of course, gives us all the functions. Remember, in ThreadWeb, we're seeing some read functions and some write functions. So these are, it's just the same thing as this. The ones on blue are actually read functions, so they don't cause gas. So for instance, you want to know the name of our token, it wouldn't cause gas, so we can just check. And of course, Ethereum didn't pop up my wallet address because it's a read function. So if you want to know the owner, it's going to give us the address that was provided and of course the symbol. But our total supply will be 0 because it hasn't been minted to anyone. So basically, the colors on blue on Remix are actually read functions, and the colors on yellow are actually functions you pay gas for. So, but there is another color that is not here. The color is red. So red is when you are sending token to someone else. It kind of like pop up red so that you know. So the first thing we should do is to mint some tokens, right? So let's mint let's mint to the same wallet address so that we can just confirm. In this case, let's mint 200 so that we'll not confuse it with the first one. So of course, it's going to pop up our MetaMask so that we can conclude the transaction, or rather confirm the transaction. So we confirm the transaction and we wait a bit for confirmations on the blockchains. So now we have 31 nodes or 31 nodes have confirmed our transaction. And of course, it's going to give us a receipt. Normally, we can just go to a Tascal and get it, but let's check the receipt from here. So this is the transfer, right? So you can see here that's minted 200 of these tokens to this wallet address. So let's check our Explorer. We should come down. All right. So we'll go back to our Explorer and let's just refresh this. Okay, so all right. You can see we called the mint function and it sent something to this. So let's get the contract address again. Let's see. So that we can see it on our MetaMask. When we pop up our MetaMask, we can actually see the token there. So I'm trying to get the contract address. All right, this is the contract address. So back to our MetaMask and same thing, tokens, import tokens. We just put the contract address. And of course, so we got the right contract address this time, but my token balance cannot be 0. Let's see. Let's see. Let me confirm the address we minted to. Okay, so we did something very funny and very, very we actually minted the token. It's my error anyway. This is the address of the smart contract. So we actually minted the token to the smart contract. It's fine. So I'll just copy my wallet address this time around. So you see that even the smart contracts can receive tokens, right? So let's see. I hope I got that right. Yes, I got that right this time. So I call the so wait for confirmation. All right, we have a confirmation just to verify this time. So you can see here, we minted that token to our smart contract address instead of my address. So let's see what happens when we refresh. Same thing. No. Yeah, let's see. Okay, so So I did something that I wasn't so. Remember, our decimal is 18. So normally that means it's 10. What's supposed to be like 200 times 10 raised to power 18. So since I made 200, it's going to divide it by 10 raised to power 18. So that's why I'm having 0 point all of this, then just 2 at the end. So if I wanted to have the 200, that means I had to reverse it. It should be 18 decimals. So basically, this is just an overview of how we can actually deploy smart contracts on the blockchain without writing a line of code. It's not just about the ERC20 tokens, but you can do a lot more with it. You can build NFT marketplaces, of course, then you interact with the smart contract. So that's the lecture for today. I'll start taking questions because I think we've gone deep into time. So thank you very much, guys. I'm open to questions, and of course, you can always raise your hand. Then you will called upon to ask a question.
So guys, it's been a very engaging moment. So drop your questions right now. Let's check the chat while I check the YouTube.
I'm still unable to access pre-recorded videos. Okay, please, to access all the videos, just go to follow our YouTube channel at Ethereum Nigeria. All the videos for the bootcamp are there, and of course, maybe we'll just make a compilation of the links to the videos, but it's there on our YouTube channel. Just go there, subscribe, so that you can always get notifications on new videos. All the videos are there, please. So it's 71193 the gas. Yeah, but it was measured in the smallest unit, right? So these are other complex stuff. So one eta, the smallest unit of eta is GUE, right? So it takes about 10 raised to power 18 GUE to be 1 eta, just like what happened. So there are standards for it. So when they say 71193, they were measuring it in the smallest unit of eta. What is the meaning of token and what is it used for? So a token is your cryptocurrency. Bitcoin is a token, Ether is a token, Matic is a token. So a token is generally a digital asset that represents a store of value, just like Bitcoin. So basically, Bitcoin's, Bitcoin cryptocurrency. What we just did was a cryptocurrency, right? So there's no difference between the token we created with Bitcoin. It's the same thing. These are digital assets. Just that Bitcoin has a store of value, and the one we created, and of course, it's on the test net, so it doesn't have a store of value yet. So normally there are protocols and procedures to go about. That's where you talk about tokenomics. So you should also check out our Medium channel, Ethereum Nigeria. There are a lot of stuff. There are a lot of articles on these things you can read and familiarize yourself with it. So basically, the token we created is a cryptocurrency. It could be used for anything. It could be used for membership to a private group or a private community. It could be used as a store of value. Can be used for any purpose at all. So I don't see any hands up. Okay. All right. In the absence, okay. Osinachi, your hand is up. Okay, please go ahead.
Okay, thank you, sir, for the lecture. Yeah, it was quite impressive. I would like to understand something. I noticed you were talking about main table and total supply. So let's say during creation of my token, I impute a value which I want to be 100 or so let's say a certain value for the total supply. Will I still be able to mint more token after deploying it? Or subsequently, I cannot mint because I've selected a specific number of token? Sir, I don't know if you get it.
Yes, I get it. So the Ethereum standard is that if you're having a total supply, you cannot exceed that total supply. But if you're the one writing your own smart contract, you can have that logic that you have a total supply, and then you can always increase your total supply, but it will not lie well with your community, right? So the trust will not be there. So if you are already if on deployment, by deployment means minting this smart contract, or rather, verifying and also adding this smart contract to a blockchain, then miners validate it and add it to the blockchain and all of that. At that point, remember, smart contracts are immutable. So the standard is that if you have a total supply and you are telling the agreement on your smart contract is that this is the amount of coins we want to produce, it will not exceed that amount, all right? But like I mentioned, that's the standard. But like I mentioned, if you are the one writing your own smart contract, you can choose to put whatsoever logic you like. You can have a total supply and then the possibility of increasing your total supply. It's very possible, but then I don't think your community members would follow you so much because they won't be trust. But yes, if you have a total supply, you cannot increase it. That is the standard, except, of course, you can write your own smart contract and impute your own logic to it. So please, what is the meaning of minting a token? Okay. So minting a token simply means creating the token, right? So the smart contract that Dead Web provided us, and of course the one we chose or selected on Open Zeppelin, the idea was that first of all, create the token, create the smart contract, let it be on the blockchain, but don't mint any token. Now, minting the token was calling a particular function mint. So once you mint, you're telling the smart contract, okay, it is time to create some tokens. So you specify the amount of tokens you want to create, and the smart contract creates that for you. But if you had a total supply before then, it's when you are deploying the smart contract and the process of adding the smart contract to the blockchain, that is when the tokens are created. And after that time, you cannot create, the standard is that you cannot create more tokens. I hope I answered you. So, okay, Dean Sunday, please go ahead.
Okay, thank you so much, EdTech, Mr. Etok. Your lecture has been very engaging and interesting. And my question is this, concerning minting NFTs. Are we going to do a different session, or this particular process is just the same process, just that the NFT own, you have your image, as it were, prepared or something?
Yes, of course, it's the same process. If you go to Open Zeppelin, let me just okay. Let's just look at my screen just one last time. Let me explain that concept. Okay, so this is my screen. All right, so if we go to Open Zeppelin, right? This is ERC20 token, the one we minted, of course, the one we created rather. So this ERC7, these are different standard, but these 721 and 1155, these are NFTs, right? These are NFT standards. So you can just do the same thing, come here, and of course you see it's now empty. So you can then choose your name, your symbol, your base URL. This base URL is like where is your image stored. So you have to use a decentralized storage to actually store your image. There are a lot of platforms that offer that. There's Filecoin, of course, which is our major partner and sponsor, and there are other platforms that you can actually use for decentralized storage. So it's just the same thing. You choose what you want to do with it. It gives you the code. You take it to Remix and deploy it. And also on Dead Web, of course, if we go back to the contracts, I think here, let's try, okay. If you go back to deploying a new contract, you should provide options for NFTs. Yeah, you can create an NFT drop, which is of course a release. You can have multiple NFTs and just choose to release them. Of course, you can stake your NFTs, and there are a whole bunch of things you can do with NFTs here, like NFTs collection and all of that. So it's basically the same thing. And it's easy. There are also documentations for this on the website, so it's easy to follow along. So it's basically the same thing.
Thank you so much. Thank you, sir.
I can see myself watching this video. Okay, all right, Precious, please do. Any more questions, guys? Because we have really
Yes,
gone.
sir, I still have a question. I noticed you were talking about the mint function. So I would like to understand are these predefined keywords used in this Solidity language, or like are they building keywords, or they are like user built keywords, like user can create them?
Okay, so basically, the functions I mentioned, if you notice when we're on Open Zeppelin, there is a function mint, right? So these functions, like I explained in class the other time, these are the terms and agreements of the smart contract. So if you have a function mint, the agreement there is that, okay, anytime somebody calls this function, create so amount, the specified amount of token the person wants, create it and send it to, sometimes, like, notice when we use third web, I couldn't put an address. So it just sends it to the address that calls that function that makes that call. But when we're using Open Zeppelin, see, it gave an option where I can actually put any address I want. So it's just the concept of the smart contract that every function you call, you're calling a term, or you're trying to meet a term and condition. Like if you call the mint function, which is to create new cryptocurrencies, new tokens, what it does is that it first checks, but then there were no, except for the Open Zeppelin, yes, exactly. When we had the Onebu, if I used another wallet address to try to mint the smart contract we deployed with Remix, it will not work because I already, when deploying it, I said um, the Onebu from Open Zeppelin, the Onebu standard, of course, it makes it impossible for another wallet address to call that function. It's only the wallet address that deployed it that can call it. But that wasn't the case with third web. So on the third web, that's our contract address. Anybody can pick it up and then mint tokens to themselves. I don't know if you get me.
Yeah, I get it now. What I was just trying to understand it. That means that function, that's the main function, is like most times is a function that is already inbuilt, like in Solidity,
No, it was
depending
not
on what
inbuilt.
we.
It was written. It was written. It was.
Okay.
Let me Just to clarify that, I'll just, I think for the very last time, share my screen. All right, okay. So let's go back to our Open Zeppelin. This is Open Zeppelin. Now, this is the smart contract. It always has a keyword contract. Then in the constructor here, you are specifying that once this contract is deployed, do this thing. This constructor is a function, but it's like a function that immediately executes once you deploy the smart contract. So any condition that is here, it's executed once the smart contract has been deployed. So basically, if we come down to, okay, let's just start some few things, but we won't be deploying it. Let's call this, okay, Sinachi, since you asked the question, let's call it Osinachi and OSI for that. And then for the base URL, we'll just give you something. Let's leave it. All right, can always leave it. So what do you want to do? Remember, this is the constructor, but look what happens when I begin to add features to it. If I say I want it to be a mintable, you see this function now. So now, once you click on any of these things, we are now customizing it. So this is a function that will be called every time someone needs maybe this mint from this saved mint function that will actually create a particular NFT, right? So this saved mint is going to mint this NFT to a particular wallet address and then give it a token ID. So everybody that calls this mint to interact with on the blockchain is actually calling this function mint. So if you want to make it bondable, it will be in, it's okay, bondable says initial honor, okay, all right. Then enumerable, you see, it's updating other functions now for us. So now you see that you have multiple functions that you can call on this smart contract. So every time you call one of these smart contracts, which is it first checks the terms and condition of that function. If your wallet address meets that condition, then whatsoever you called it to do, it will interact with the blockchain, and it's decentralized, so nobody can actually, there's nothing stopping you from calling the smart contract if you have access to it. So these functions basically are just the terms and conditions in the smart contract that you get to interact with after the smart contract has been deployed.
Okay, thank you, sir. So, sorry, I have to ask another question. Regarding, let's say the price of tokens. Let's say, how does the, let's say some user is trying to mint tokens. How does the smart contract identify the price range and the price of the specific token and what the exchange?
Okay.
I don't, yeah,
No,
I don't know if you want.
the smart contract doesn't know the price, right? The smart contract only knows the tokens. So it's the tokenomics that determines the price. So just go to our Medium page, and there are a lot of stuff you can actually read from there that will also add to your Web3 journey. So tokenomics was well explained on our Medium page. So the smart contract doesn't know how much one Ether is worth in dollars. It just knows it has, maybe if the smart contract is receiving Ether, so maybe the smart contract knows, okay, my balance is maybe 5 Ether, 10 Ether, but the smart contract doesn't know that one Ether is so and so dollars. No, it doesn't. You can always swap your token, but the smart contract doesn't know. It just knows its token. So it's the tokenomics behind the token that actually determine the price of the token. So do well to just check out our Medium page, medium.com/Ethereum Nigeria. And of course, there are a lot of stuff you can read to catch up on that. So I think that's that for today. Thank you guys for always attending classes. Of course, I know that you're always learning a lot also, but I always advise us to ask questions in class so that we can have better understanding. So that's my lecture for today. Thank you, guys.
Okay, let's appreciate our lecture. A wonderful work. I can see many of you saying you watch the video over and over. So please do. Please record it. Yeah. Over time, you get to understand. But this an intro, and then you have the video. Watch, read. So we have the Medium page, and we want every one of you to subscribe on the Medium page. YouTube. We want every one of you to subscribe on the YouTube. We want to follow us. We have the LinkedIn as well. So you have like a couple of 4-5 tasks to do. Yeah, okay. Yeah, you need to you need to understand that before you can ask questions. Right. So if you want hands-on Ethereum Lagos Bootcamp or Ethereum Abuja Bootcamp or Port Harcourt or Anambra Bootcamp 2024. Not much. Thank you for your time. We're calling it a wrap. Let's continue the discussion on the Telegram. See you. Have a good night. God bless.